In this session we're going to use this simple line beam model to look at direct method influence and Eurocode loading on a line beam model. If I switch off the fleshing, you can see this is just a simple line mesh. Now if I go to the attributes menu and influence, we have two influences. The reciprocal theorem has been in the software for some time and can be used for grillages and slabs, whereas the new direct method in 15 can be used for grillages, slabs and line beam models. So I'm going to choose the direct method. Now the entity I'm going to choose is force moment. For this case I'm going to choose my. Now the influence type can be unaveraged, averaged or automatic. I'm going to choose automatic in this case and I'm going to call it bending my. If I OK that, the attribute appears in the tree view. I'm going to select two nodes in the model and I'm going to drag the influence onto the model. At this stage I have to set up the properties of the direct method influence. So to start with, I choose the search area deck to load this area of the model. The grid that I'm going to use is in the global X direction and it's going to be 7 meters wide. The grid settings and load settings, I'm just going to use the default values. So in the analysis tree view now, I have two influences. If I solve these, I can then look at the influence shape. Okay, so if I just move the model around now, what we're looking at is the influence shape. If I switch off the fleshing, go to the layers tab and switch off the delete the mesh, what we're looking at is the influence shape. Now the influence shape is showing you where I should load or not load the model. Now the blue areas I should load, the red areas I shouldn't load. Now if I go to the influence, right hand mouse button and find, it shows me the point on the model that this influence shape is for. If I set active the second influence and hit find, again this will show me on the model where the influence is for. So this is a point in the deck. So we now have the two influences and we know from the influence shape and the colours on the contours where the model should be loaded or not loaded when we look at the live loading. Now I'm just going to switch on the geometry and I'm going to switch on the fleshing. Now these two lines are 7 meters apart and they represent the limits to where the traffic loading can go. I'm going to select them and then I'm going to go to the bridge menu to pick the vehicle load optimization tool. Now I'm looking at the United Kingdom and I'm going to use the Eurocode EN 1991. In the optional code settings I'm going to choose the characteristic combination and I'm using an SV80 vehicle. All the other settings I'm going to leave as default. Under the optional loading parameters, I'm going to use the longitudinal and transverse settings as 0.25. The curbs, I'm going to use these lines that I've selected to bring in the information. And the set influences, I'm going to look at both influences. Now here, I want to load the negative or the blue areas on the contour pattern. Selecting OK will calculate the load patterns and load them back into the analysis tree view. So let's set active the first one. I'm going to switch off the fleshing and this is the pattern of the loading that's been created. So we have a remaining area, we have a couple of tandem loads and the associated lane loads. If I set active the second influence, you'll see that we have an SV80 vehicle that's displaced one of the tandems and the lane loads. Down this edge we have the 1 meter remaining area. Now rather than just calculate two influences, I'm going to go back to the attributes tree view and create a few more influences. So force moment, I'm going to choose FX unaveraged. I'm going to call this axial load FX. Once I've created this, I'm going to select a point on the model where the arch and the upright intersect. Now this will create two influences. If I set one active, you'll see the influence shape straight away. Now the important thing here is I don't need to rerun the direct method influence analysis to see the shapes. They'll appear instantly. Now I have two because I have an influence for the arch and also an influence for the vertical member. Now rather than just creating influences for components that already exist in LUSAS, I can create a user-defined result where I specify my own component. Now I'm going to choose force moment, and I'm going to create an expression where I'm looking at my divided by 100 plus fx divided by 500. So it's a my-fx interaction equation that I'm creating. Now, this is just one that I'm making up, but it's just showing you that you don't have to work with the LUSAS components. You can actually create your own components to create inferences for. Now I'm going to call this user-defined result, or UDR. I can go to the attributes menu, influence direct method. I'm going to choose force moment, but this time the component is the one that I've just created, UDR. I'm going to call this UDR, and I'm going to pick a node on the structure and assign this new influence to that node. Okay, so if I now look at the influences that we have for these nodes, you'll see the influence shape for this user-defined interaction equation. I can now edit the VLO analysis properties. Now, the optional loading settings and the code settings and the curve details I'm going to leave the same. I'm just going to add the 4 new influences. Again, I'm going to load the negative or the blue sections on the screen. Now, if I rerun this, I'm going to calculate the new load patterns to go onto the model. Once those load patterns have been calculated, I could view them, but actually I'm just going to go straight ahead and run the analysis. Now, the first 2 analyses don't need to be run, it's only the third that needs to be run. Once I've run the analysis, I'm going to go to the layers, I'm going to switch off my deform mesh, I'm going to switch on my mesh, and I'm going to switch on my bending moment diagram. Let's have a look at the elevation of the structure. If I click in the Y box here, I'll be able to see the elevation, and what we're looking at is the bending moment profile on the model. If I set active another load case, slightly different load positions and obviously a different bending moment profile. To clean up the image, I could switch off the loading arrows, so I'm just looking at the bending moment profile on the screen.